Hey guys, today's video is going to be about conditional probability. So here's a little bit about conditional probability. Given events A and B, so one event then the other, conditional probability is the probability of an event B occurring knowing that event A has already happened or already occurred. That's the fancy word. All right, so the way that we note this, the notation is probability of B after A. Okay, so B slash A. That is read as the probability of B given A. So the probability that we draw a red marble given we've already drawn a blue marble. Something to that effect. The conditional probability formula is probability of B given A equals probability of A and B, which is what we worked on last time, over probability of A. So we are going to use this handy dandy shortcut. So we have a denominator and a numerator. That's the bottom and the top of a fraction. For the denominator, we say, if we know A, how many are we choosing from? That's our denominator. Now, out of those options, how many choices actually work? And that will be our numerator. Now, let's do some examples, and this will get a lot easier as we go. Number 1, Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? So we ask ourselves first about the denominator. So here's our fraction bar. For the denominator, if we know A, so the given, whatever follows given, that is A. The thing that we want the probability of is the B. So if we know A, if we know that the card was red, how many choices do we actually have? There are only 26 red cards in a deck. Now, out of those red cards, how many choices work? How many choices are queens? So there's one queen in each suit, and there are 2 red suits. There are only 2 queens that are red. The other 2 are a black card. So 2 out of 26 reduces to 1 out of 13, and that's our answer. Number 2, a number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it is an odd number? So the given part is A and the other part is B. So if we know that it's an odd number, how many are we actually choosing from? So we have 1 through 100, and every other number is an odd number. So half the numbers are even and half are odd. So half of 100 is 50. We have 50 even numbers to choose from. Now, out of those 50 even numbers, how many are perfect squares? So what we're going to do is we're going to list all the perfect squares that are less than 100 and then mark out the ones that are odd. So perfect squares are when you multiply something by itself. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. So those are all of the perfect squares that are in 1 through 100, but these have to be odd. So they cannot be even. This one, no, 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 and no. So we have 1, 2, 3, 4, 5 different options out of the 50 choices, which is 1 out of 10. All right, there are 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take spinning class. Okay, so here's a trick we're going to have to learn. Anytime that you have people that do both things, this is a type of problem you're going to see. You know, this many people do this many people do this, and this many people do both. So you've got to figure out where everybody fits in. So anytime that you have that, you want to do a Venn diagram. So that's what this is. So the left circle, okay, I actually decided to make them different colors to help. So the pink circle represents, and it doesn't matter how you do this, but we're going to say the pink circle represents spinning and the green circle represents yoga. So this is both, this space in the middle. So you always start with both. 15 people that take yoga also take spinning. So 15 people are here in the middle. Now, it says 62 people take yoga. So we have 62 people, but 15 of them are already here. So we're going to do minus 15, and that's going to give us 47 people that only do yoga. So 47 plus 15 is our 62 total people, but 47 of those only do yoga. Now, the spinning class is 48 people. So we have 48, but 15 of them are already accounted for. So minus 15 gives us 33 people that only spin. All right, so now that we know where everyone fits in, we have 33, 15, and 47. It says, if a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take spinning class. So the thing that's given, the thing we know is that they take spinning. So if we know that they take spinning, then how many are we actually choosing from? So all of the spinning people is everything in the pink circle. So it's 33 plus 15. There are 48 total spinners. Now we want to know, out of those, how many choices actually work. So out of those spinning class people, how many actually take yoga? There are 15. So 15 out of 48 chances that we choose someone who does yoga if we know that they're in spinning class. So that's going to equal 5 out of 16. If you're having trouble picturing this, like imagine you walked into a room and there are 48 people doing a spinning class, 48 people on stationary bikes at the gym. And you were trying to find someone in that room to come and be your yoga partner. You would want someone who already does yoga. And so you would have a 5 in 16 chance of choosing someone randomly who actually does yoga. Number 4, of the 30 students in Mr. Smith's math class, 13 are athletes and 9 are in band. 3 of the athletes are also in band. If one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. So once again, we will do a Venn diagram. We always start with the both. So let's label everything. There are 30 total students in math class. 13 are athletes. So we're going to have athletes. And 9 are in band. So we always start with both. 3 of the athletes are also in band. So we've got 3 in the middle. 13 athletes, so we'll do 13 minus 3 gives us 10 total athletes, or 10 only athletes, I apologize. And then there are 9 in band, so 9 minus 3 gives us 6 that are only in band. Now, we have 10, 13, 19. There are only 19 people represented here, and there are 30 students in Miss Smith's math class. So that means that we actually have 30 minus 19 equals 11 other students. So these students do not participate in either. All right, so now we've figured out where everybody belongs, what group they're in. So now we ask ourselves, if one student is chosen at random, find the probability that the student is in band if it is known that they are not an athlete. So if we know that they are not an athlete, how many are we choosing from? So that means no one in the pink circle counts. Only the ones not in the pink circle count. So there are 17 total students who are not athletes. So these guys don't count. Of those 17 students, how many are in band? There are 6 in band. So 6 out of 17 is our answer. So the next topic on this is two-way tables. And basically these have already organized the information and the people into groups, and you just get to read a chart. So this is kind of nice because everything's already organized for you. So a two-way table records data that pertains to 2 different categories. Example, the table below shows the result of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. So this tells us that 18 boys prefer football, 18 boys prefer hockey, 6 girls prefer football, and 16 girls prefer hockey. All right, so this asks us, remember that the order of this is probability of B given A. Okay, don't forget that it's in order B, A. All right, so how many people prefer football given that they're a girl? So whenever we use our shortcut, we say, okay, if we know that they're a girl, how many choices do we actually have? So the girl column is here. 6 plus 16 is going to be 24 girls. I'm sorry, I lied. 22 girls. So out of those 22 girls, how many prefer football? That would be this number, 6. 6 of the 22 girls prefer football. That reduces to 3 over 11. Okay. Probability of being a boy given that they prefer hockey. So given that they prefer hockey means that we are choosing from these numbers. So that's 26 total that prefer hockey. And we want to know how many of those are boys. 10 of those are boys. So 5 in 13 of people like hockey are boys. All right, so number 5 asks us 4 different questions about the exact same table. So a quick little shortcut that we can do to make it easier is to add up each column and add up each row, because that will make it faster for us to do our calculations. So when we add up 19 plus 25 plus 38, we get 82 total French. I haven't even read the prompt yet. This is what class they take. So 82 people take French and 68 total people take Spanish. Of the 150 people selected, there were 42 6th graders. 37 of them were 7th graders and 71 were 8th graders. So we just added these together to get that, and then added these together to get that. So part A says the probability of a 7th grader who takes French. Okay, so you need to pause. There's no bar in that. So that's missing from part A. So that means that this is not conditional. So don't get caught up in that it has to be conditional. So we just want to know, out of all the students, so there are 150 total students, what's the likelihood of choosing a 7th grader who takes French? All right, 7th grade takes French. That's this number. There are 25 of them. So that reduces to 1 out of 6, and that's your answer. Now, for part B, we will do a conditional probability. So we want to know what's the likelihood of choosing an 8th grader if you know they take Spanish. So if we know they take Spanish, how many are we choosing from? 68 total people take Spanish. out of those Spanish taking students, how many are 8th graders? 33. And that does not reduce. Okay, part C. The probability that someone takes French given that they're a 6th grader. So if we know they're a 6th grader, we only have 42 choices. And of those 42 choices, 19 of them take French. And you cannot reduce that fraction either. All right, then part D says the probability that you choose a 7th grader given that they take French. So if we know they take French, we have 82 to choose from. Of those 82, 25 are 7th graders. And that one can also not be reduced. All right, I would like for you to pause the video here and try number 6 on your own. All right, it's the same as number 5, not a big deal. So the only thing that you should do different on number 6 is it doesn't tell you how many total students there are, so you have to add all these up. So for one of the things, you'll need to know that there are 200 total students. And then don't forget to do all your little totals for each column. All right, you can check yourself here. Pause if you need to. Now, the last thing we want to look at today is something called a frequency chart or frequencies. And there are 2 types of frequencies. They are called joint relative frequencies and marginal relative frequencies. I'll point these out to you after we do the chart. So I want to show you how to fill in the chart first, and then we'll talk about the difference. So the table below shows the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, or no bags. Find the joint relative and marginal relative frequencies, then find each probability. So what this means is we're going to figure out how many, what percentage each box is of the total number of people surveyed. But when we write it as a frequency, we just leave it as a decimal. So to figure out what goes here, we are going to do 16, because you can see that this is the same as this and this is the same as this. And then we have totals. So it's kind of split into a, different shape chart. So we'll worry about those total columns and rows in a minute, but if you look, we have the same number of boxes here as we do here. So the first thing that we need to know is all of these added together. There are 160 total people, total passengers that they interviewed or that they surveyed. So let's do this box first. We want to know the joint relative frequency of someone in first class with 2 bags. And the joint relative frequency is the values in each category divided by the total number of values. So the values in that category are 16, and there are 160 total values, or total number of values. So 16 over 160, we want to write this as a decimal, gives us 0.1. So that is what goes right here. All right, and that kind of means that if we were to make this a percent, it would be 10% of the time this is what happens. All right, so this is going to make more sense as we go. Right now, we're just going to follow the rules and fill it in. So this one is going to be 12 divided by 160. And it is going to give you 0.075. This one will be 2 divided by 160, which will give you 0.0125. This one will be 52 out of 160, which is going to give you 0.325. The next one is 60 out of 160, which is going to give you 0.375. Then we will do 18 divided by 160, and that gives you 0.1125. Now, to find these total columns, this column and this row are both marginal relative frequencies. And all that means is when you combine multiple frequencies. So we're going to add these two together to get that. So 0.1 plus 0.325 gives us 0.425. When we add across the next row, we get 0.45. Then we get 0.125. Now when we add our columns, we get 0.1875 and 0.8125. If we did this correctly, these should add up to 1 and these should add up to 1. And that's how you know you did it accurately. So the total number of all the frequencies should equal 1. So now we're going to use this to ask questions, or to answer questions. We want the probability that a coach class passenger that did not check any bags. So coach class, no bags. That's this number. So whenever we talk about frequencies, we give those as a percentage. All right, when we're using frequencies, we give them as a percentage. So if the frequency is 0.1125, we're going to multiply that by 100 to get 11.25%. So 11.25% of the people were coach class passengers that did not check any bags. All right, so part B, a first class passenger that checked at least one bag. First class, at least one bag. So that's going to include both of these numbers. So when we add those together, 0.1 plus 0.075 equals 0.175. So then we're going to multiply that by 100 to turn it to a percentage, which is 17.5%. So 17.5% of people on this plane had more than one, or of first class passengers on this plane had more than one bag. All right. All right, we want the probability of a coach class passenger given that they checked one bag. So remember, this is when we do the probability of B given A. So if we know they checked one bag, then that means that we have this many choices, or that's the frequency that will go in the denominator. Now, of those, how many were coach class? This many. So 0.375 is the frequency of coach class customers that had one bag. And when we do this division, we're going to get 0.83 repeating. And when we multiply that by 100, we are going to get 83.3%. So 83.3% of the people that checked one bag were coach class. All right, so now we want people that check two bags if we know they're in first class. So if we know they're in first class, we have this many choices, so 0.1875. And we want to know out of those how many checked two bags, 0.1. When we do this division, we get 0.53 repeating. Then we multiply that by 100 to get a percent, and we get 53.3%. All right, guys, that is all for today. Have a great day. Thanks for listening.